Hi, I'm Joby and welcome to Node 7 Electronics. If you can't tell by what's on screen right now and the title of this video, today we are doing breadboarding. This is going to be a relatively short video because I'm not going to be doing too much of actual circuit building on the breadboard, but I am going to cover the basics so you can build just about any circuit that you could want on the breadboard. So let's start off with the basics. When you first look at a breadboard, there's a whole lot of holes, and you might be wondering, how are those connected, and how can I build a circuit with it? And let's go over that right now. So let's first cover the power rails. These are these strips that connect, or that go in between each of these main circuit building sections. And inside the breadboard, there's metal connecting one row of these holes all the way down, and another row of those holes all the way down. And that is happening on each and every one of these long strips with the red and the blue to symbolize positive and negative. So on my breadboard, I've got all of these strips all connected so that if I apply power to one of them, all of them have power. Now, if you're building a circuit with different voltages, you might not want this. You might want to have one strip for 3.3 volts, for example, one strip with 5. That's up to you, and you can configure the breadboard the way you like it. Alright, now that we've gone over the power rail portion of the breadboard, let's go into the main circuit building portion. So each row this way consists of 10 pins, or 10 holes rather, with a line running down the middle. This line separates these into 2 rows of 5. Now each one of these rows of 5 is connected. So this pin, this pin, this pin, this pin, and this pin are connected. This pin, this pin, this pin, this pin, and this pin are connected. Now this hole is conveniently sized so that a standard dip package will fit in between with one leg on either side of the pin, therefore breaking out the pins of this dip package. So this first pin on this dip package is connected to these 4 pins on the breadboard, and you can plug wires into those to break it out to another part of the breadboard where you might have, say, an LED hooked up. Now that we've covered the basics of how a breadboard actually works, let's go and try and build a simple circuit. So let's start with power. I've got this simple 5-volt wall adapter here. It's rated at 5 volts at 1 amp, and I've cut off the small barrel jack that was on the end, and I have simply put on a couple male headers, and that will allow me to plug this into the breadboard to provide power to all the power rails. So now that I've done that, I can simply plug that into the wall, and then let's try hooking up an LED. So I've got a nice little green LED here. Let's zoom in a little. And on an LED there's a flat portion. So that flat portion is the part that connects to ground. So you can see right there that this side has a flat on the edge and this side is fully rounded. So I'm going to plug this into the breadboard, let's just say right there. And just keeping in mind the flat portion is towards me. Let's grab a resistor. I've used a LED resistor to calculate the value that I would need for this resistor, and then I will simply plug it into the positive end of this LED. Insert that. So now we've got a resistor and an LED, and that's a current limiting resistor to prevent the LED from to prevent too much current from flowing through the LED and causing it to burn out. Now we're going to take a jumper and connect this end of the resistor to 5 volts that I've got running through all the power rails on this breadboard. And then I will take another jumper and hook it up to the ground. And as you can see, I'll switch off the light here. That LED is now running. If I remove power, now it's off. And then if I simply plug it back in, LED is lit. So now I'm going to connect more LEDs. First, I'm going to rearrange it to be a little bit more easy to work with. So I'll unplug all of this, and I'll use this resistor to span the gap here, and then I will plug the positive side into that one end of the resistor, just like so, and then I will use a jumper to connect the other end of the LED to ground. And now another jumper can be used to connect the opposite end of the resistor to 5 volts, and it lights up. So I'm going to repeat that. I've got some more parts here, a couple more resistors. So let's plug in another LED with the ground in this case facing away from us. Grab our resistor, simply insert it right here, use another jumper and connect that to positive, and then connect the ground end of the resistor, of the LED, sorry, to positive, and that's lighting up. So I'll repeat that a couple times and you can see how quick you can build a circuit on a breadboard. Alright, so I've added 2 more LEDs to this and 2 more resistors and then connected them up. So here we've got 4 LEDs running. And I'm going to conclude now just saying why, once you're done prototyping your circuit on a breadboard, why you're going to want to move to something more permanent like perf board or a full-on printed circuit board. And that is, breadboards are meant to be prototyping boards for testing. You wouldn't want to build something, solder it all up on a board like this, only to find out that it doesn't work, and then you will need to desolder and rebuild the circuit on that, which is much more difficult. On this, if something's wrong or you didn't lay it out very well, you can just unplug it and plug it back in however you need. So you saw earlier when I changed the layout of the first LED, that's another thing. Instead of having, if I was building it on this, I would need to desolder that and then resolder it, which would be a lot more work than simply unplugging the parts that need to be moved and plugging them into a more suitable location. But then you might be wondering, why not use breadboards for everything, even finished circuits? And the thing with that is breadboards are, again, a temporary prototyping thing. Things can get jiggled loose and they don't provide the best connections. Once you know that something works, you're going to probably want to build it on something more permanent, like a perf board, or even get a PCB made for that professional look. And one final thing about breadboards is they're kind of expensive, so you wouldn't really want to be using them in place of your regular construction techniques. So thanks for watching, and hopefully I'll have some new videos out every week, every Wednesday. This has been a Node 7 Electronics video. Please like, comment, and subscribe.